Welcome back to all my Russellins. Those are my subscribers. Uh, you're now called Russellins. You're part of the Russell crew. It's like Pennsylvanians, but just Russellins. Vertical shifts. Let C be a positive number. The graph of g of x equals f of x plus c is the graph of f shifted upward c units. The graph of g of x equals f of x minus c is the graph of f shifted downward c units. All right, whenever we're shifting a graph vertically, we have absolute value of x plus 4. That's our g of x, and our h of x is absolute value of x minus 3. Now, what would the parent function for this one be? Yes, parent function, f of x is the parent function, and that would be the absolute value of x. All right, so then if I'm shifting it up vertically, the plus 4 is outside of the outside of the brackets, which means it's going to be a vertical shift. My original parent function would be down here at 0, 0. Then if I'm shifting it vertically, that would mean I'm going to take the whole thing and shift it directly up 4 units. So that would be g of x. So this would be g of x. I don't know how I ended up with another curly Q on there. My thing is like lagging. You know what else is lagging? The number of people who like and subscribe to my videos. So that would be g of x. To find h of x, we would take our original and shift it down 3 units. And that would be h of x. We're just picking it up and moving it down. That's what shifting graphically does. It moves it up and down. Right. Yes, we move it down 3. The original parent function was at 0, 0 for our starting point. The minus 3 means that starting point moves down 3, and so does every other point with it. The plus 4 meant that it started at 0, 0 and moved everything up 4, picking up the whole graph and shifting it up and down. That takes us to horizontal shifts. Let C be a positive number. Then the graph of g of x equals f of x plus c is the graph of f, our original graph, whatever the parent function may be, shifted to the left c units. C unit, go shorty, it's your birthday. I don't have rights to that song. like, and subscribe. I'll leave it in there. If it's less than 20 seconds, they can't do anything about it. Yeah. I don't know if that's the actual number, but there's like a deadline for it. I think there's an actual number where it stops. I think it's 20 seconds, so. All right. If everyone's good, we'll move on to the next one. Okay, this is an example of a horizontal shift. So first, what would our parent function be for this one? Right, it would be the reciprocal function, which is 1 over x. So that's the parent function. Now you'll notice that my minus 3 is in the denominator. That tells me that it's shifting horizontally. If it was like this, 1 over x minus 3, that would be a vertical shift like in our last one. Everyone see the difference there? So because it's in the denominator, that tells us that it's going to shift horizontally. And it actually works the opposite way that you would think. If you look at this, you would think if I'm shifting left and right, a minus 3 would shift the whole thing to the left, but it's the opposite. It actually shifts the whole thing to the right. And so for that reciprocal function, we would have an asymptote at 3, which is nothing more than a vertical line that it doesn't cross. And so we're taking the original function, which would have looked something like this, and we're making it over 3 instead of going like this at 0, 0. Wow, I make pretty pictures. So this would be g of x. If I was doing h of x, that would have shifted the whole thing to the left 4. Why did that switch to red? Not that it matters, but... What do you mean by switch to sign? Yes. Because it's the opposite of the way that you would think it would be. And that takes us to our next one, which is a reflection. The reflection says the graph of g of x equals negative f of x. It's the graph of f reflected across the x-axis. And the graph of g of x equals f of negative x is the graph reflected across the y-axis. And tomorrow I'll show you some examples of reflections as well as our last type. There will be homework tonight on horizontal and vertical translations, just seeing if you can graph that stuff.